Hello class and welcome to Geometry Pre-EP. This video corresponds with section 1.0 which was covered in class. Okay, so going over the terms, point is no dimension represented by a dot. It's named using a capital letter. Very important, okay? Example point A. So as we can see, those two are the same thing. One is how you write it, the other one is the symbolic representation. Okay, line, one dimension, extends forever in both directions, represented by a line with double arrowheads. Okay, so really important, double arrowheads. Okay, if you look to the right, there you have your two arrowheads. Okay, very important. Okay, using any 2 points in the line, you can name it. Okay, so for example, double arrowhead. Okay, AB, double arrowhead BC, double arrowhead CA, and there's many more as long as there's 2 points that are on the same line. Another way of naming it is using a lowercase letter at the end of the line. For example, line L, and we can see that it's over here. Okay, sometimes you see other letters. Okay, it can be line B, line C, doesn't matter. Okay, but if you see that lowercase letter, you can also name it. Plane, 2-dimension, extends forever in both directions, represented by a parallelogram, and it's named using 3 non-collinear points. We'll go over that in a bit. Non-collinear are points that are not on the same line. They're basically in different places. If they're in the same plane, you can call the plane grabbing those 3 points. So we have plane ABC because we have this 3 points over here. And if we see a capital script letter, it's not a point. Not a point. It's a script letter. You can also call the plane by that letter. So plane S, as you can see right there. Okay, moving on. Intersection of 2 lines, they meet at the same point. Intersection of 2 planes, they meet at the same line. Okay, so when 2 planes intersect, they're actually meeting at the line. Okay, it's the same line. They're sharing the same line. Counter example means to disprove a hypothesis or theory. Very easy example will be the term point B, represented symbolically as dot B, and then we have a counter example which just be double arrowhead AB, which this actually means it's a line. Okay, just something quick. Okay, moving on to page 2. Okay, in page 2, in page 2 we have segment, which means it's a piece of a line with no arrows. Okay, super important. Okay, no arrows. It's named using the endpoints with the bar above. So we have endpoints JK and KJ. Notice how they don't have arrowheads, it's just a segment. Okay, and we're talking about that one right there. Array has one endpoint and a line that goes forever in one direction. Named using the endpoint and another point from the arrow above, with the arrow above. Example, LM. Notice how this does not have an arrow, so I don't need an arrow here. L does not have an arrow, so L does not need an arrow. As it extends to M, that's where the arrow is, so M has an arrow. That's a ray. Okay, opposite ray, rays coming from one endpoint and extending in opposite directions. So how would you name the opposite? You would say opposite ray BA and BC. Notice how B is in the middle, so B does not need an arrow. Okay, B does not need an arrow. Midpoint, a point in the middle of a line segment, right here. Midpoint divides segment into 2 congruent segments. Segments labeled with small little bars on each segment indicate congruency. Okay, so this 2 that you see here means that those 2 are of equal measure. Okay, that's basically what a midpoint is. Okay, it divides the segment in half, it indicates it. Okay, a segment bisector is almost the same thing, except you actually see a line, array, or a segment that intersects the midpoint. It passes through the midpoint. But when they say a segment bisector, it means that the line will cut the segment in half. Angle bisector will cut an angle in half, okay, into two congruent parts. Parallel lines, lines that never intersect, and you have to memorize this symbol. You'll see it a lot. When you see this symbol, it just means that the line is parallel, okay? And parallel planes, planes that never intersect. Collinear, points on the same line. So what does that mean? It means that if I have a line, points that are here on this line are called collinear. Okay, so I can have point A, B, and C, and that's collinear. Okay. Coplanar, points raised that are in the same plane. Okay, so if I have a plane, anything that's here, that's coplanar. Okay, as long as it's in the plane. Congruent, equal length, size, or measure. You probably already know that, and you're going to be using this symbol a lot, okay? That means this is the symbol for congruent. Just a congruency statement. Segment KL is congruent to segment MN. And when you use equality, basically you're saying for sure that they're equal to each other, but you don't use symbolic representation. You say KL is equal to MN. And here's another example for the angle. Okay, moving on to the next one. Okay, angle, the space usually measured in degrees of two intersecting lines. Ways that we can name them: angle 1, angle ABC, angle B, angle CB. Very important that the vertex is in the middle. It's like super important, okay? This vertex has to be in the middle, or you can just single it out, or angle 1 if it has a number there. Acute angle, angles that are less than 90. Right angle, angles that are equal to 90, and you have the way they look on the right. Obtuse, angles that are greater than 90. Straight angle, angles that are equal to 180. Perpendicular lines, lines that intersect and form a 90-degree angle. And the product, which is multiplication of their slopes, must equal to -1. Okay, so when you multiply the slopes of the two lines, they have to equal to -1. Okay, but we'll go over that later on. Okay, complementary, angles whose sum is equal to 90. Supplementary, angles whose sum is equal to 180. Okay, moving on to the next page. Vertical angles. Okay, vertical angles means angles across from each other through intersecting lines are congruent. So as you can see, if the angles are across from each other, then they are equal to each other. Okay, this is called the vertical angle theorem. Adjacent, angles that share the same vertex. So basically they're next to each other, but they have to be sharing the same vertex, which is that endpoint here, in order for them to be considered adjacent angles. Linear pair, angles that form a straight angle, which is equal to 180 degrees. Okay, and final problem, the measure of supplement. The measure of the supplement of an angle is 12 more than twice the measure of the angle. Find the measure of the angle and its supplement. So we know that the supplement is equal to 180. Okay, so it's 12 more than twice the measure of the angle. So one angle would be x, and the supplement would be 12 more than twice the measure of the angle we don't know. And since it's supplement, we have to equal it to 180. Okay, and get the solution for me in class, and that'll be it. See you on 1.1.